we're going to talk about rainbows. Everyone, of course, had known about the colors of the rainbow. Everybody until Newton presumed that those colors were somehow getting generated inside the chandelier glass, inside the raindrop, that it was some property of the medium itself. Nobody was thinking that pure white light is composed of those colors. He puts white light through a prism, and out the other side comes the colors of the rainbow. He then, and this is what makes Newton Newton, he said, let me take another prism and put it upside down next to it, okay? And this would kind of reverse what had just happened. And when he did that, out the second prism came white light. That's why he is Isaac Newton and the rest of us aren't. So at that point, it's easy to sort of extrapolate that a rainbow is just sunlight broken up into those same colors that the prism did for you. So now, what's going on inside a raindrop? So sunlight enters the raindrop at a particular angle, all right? Actually, it comes in at all angles, but only one of those angles will internally reflect off the boundary between the raindrop and the air. Okay, this is one of the most fascinating features of optics. In other words, if I'm underwater and let's say I have a laser, so we get a nice sharp point, and I point it upwards, not straight up, but at an angle, at a slight angle. When that laser beam exits into the air, it bends. It's easy then to expect that a similar thing is happening between sunlight and raindrops that was happening between your sunlight and your prism. But the fun part is the sunlight goes inside the raindrop and bounces around a couple of times before it exits again. And by the time it exits, all of those colors have been separated out from the white light. And thus you have this participatory rainbow where all of these droplets of water participate in one coherent rainbow.